Welcome back learners. This is our second video on the lesson ray optics and optical instruments, and we are discussing about geometrical optics, not wave optics, in this chapter. So let's start. In our last video we have discussed about reflection, spherical mirrors, sign convention, and we have found a relation between focal length and radius of curvature. Now in this video we are going to discuss about mirror formula and magnification. So if you have not yet subscribed this channel, I recommend you to subscribe this channel so that you will get all other videos one by one. So let's start mirror formula and magnification. In order to understand mirror formula, we have to draw a diagram in this manner. So you may get a question on mirror formula as derive the relation between focal length f, object distance u, and image distance v for a mirror. So that is nothing but they are asking about finding the mirror formula. So you have to draw this diagram. So you can see here we have used three rays. One ray is parallel with the principal axis passing through the focus, another ray coming at an angle and reflecting back through a point B dash, and another ray is passing through the center of curvature and going back through the same path. So these three rays we have drawn to draw this image of the object AB. So this diagram is important to derive mirror formula. Now in order to derive mirror formula, what we have to do? Here you see we have to consider this diagram, and from this diagram we have to choose some triangles. So here you see triangle A dash B dash F is similar to triangle NEF. So in this diagram you can see this is A dash, this is B dash, and this is F. So this small triangle is similar to the triangle NEF. So N is this, E is this, and F is this. So this triangle. So this small triangle is similar to this NEF, this triangle. So they are similar. So using similarity property of triangle, we can write this A dash B dash by NE is equal to A dash F by NF. So A dash B dash by NE, you can see here A dash is this, B dash is this, A dash B dash by NE is equal to A dash F. So A dash F is this and NF. So this is NF. So this is the ratio we got from similarity of these two triangles. Now we can see NF is nearly equal to PF. So here NF is nearly equal to PF. So we can assume that N and P are at the same position, though here in this diagram it is not in the same position, but in actual case they are nearly equal, they are at the same position. That is why we can consider NF is equal to PF and NE is equal to AB. So it is NE is nothing but it is equal to AB. So it is obviously equal to AB. So we can replace NE and NF. We can write A dash B dash by NE as A dash B dash by AB and A dash F by NF as A dash F by PF. We have replaced NF by PF. So what is A dash F? We can see from the diagram that A dash F is nothing but it is equal to P A dash minus PF. When we subtract PF from P A dash, we will get A dash F. So we can write here P A dash minus PF. So we can put A dash F now as P A dash minus PF divided by PF. So we have got this ratio. So let us mark it as equation number 1. So now again we have to consider some other triangle, that is triangle ABP is similar to triangle A dash B dash P. So let's see triangle ABP. So this triangle is similar to triangle A dash B dash and P, this small triangle. So these two triangles are similar, and from similarity property we can write A dash B dash by AB. So A dash B dash by AB is equal to P A dash. So we can write here P A dash is divided by PA. So this came from the similarity property of these two triangles. So this is equation number 2. Now we can see here this is A dash B dash and here also A dash B dash. So this equation number 1 and 2 we can equate, and what we will get, we can see here this part P A dash minus PF by PF is equal to PA dash by PA. So this is the relation. Now what we have to do? So it is very easy. In this relation we have to use the sign convention. So if you use sign convention, you can see here PA. What is PA? From the diagram you can see P is this and A is this. So this is nothing but the distance from pole to the object. So that is object distance. So we can write object distance. So applying sign convention, we can write that object distance is nothing but minus u. Similarly, you can say PA dash. What is PA dash? PA dash is nothing. You can see here PA dash. It is nothing but the image distance. So we have to measure the image distance here opposite to the direction of incident light. So that is why it is also minus v. That is object distance. And what about PF? We can see PF is nothing but it is the focal length. So again it is minus f. So putting all this value in this equation. So all this value we have to put in this equation. Then we will get this result. So we can see here it will be minus v minus of f. PF is nothing but minus f. So minus is already there. So it will become in this way. Now we can manage all the minus and plus signs and we will get v by f minus 1 is equal to v by u. So we can divide this term, this relation with v. What will happen if we divide it? Here it will be v. So v will cancel out. Here there will be v and another v is this. So this v will cancel out and we will get this equation. This equation is nothing 1 by f minus 1 by v is equal to 1 by u. So we can rearrange it and we can write 1 by v plus 1 by u is equal to 1 by f. And again we can see this is not twice r. Actually this is f is equal to r by 2. Radius of curvature divided by 2. So we can write this equation. This is the mirror formula actually. So we can write this equation in terms of r also. So if you write in terms of r, then we will get 1 by v plus 1 by u is equal to 2 by r. So this is the mirror formula that we need to derive in this manner. Now let us see the linear magnification. So again we have to consider the same diagram you can consider for finding the linear magnification. So here you have to consider two triangles again and similarity property of these two triangles. So first triangle you see triangle ABP is similar to triangle ABP. So we can see here ABP, this triangle is similar to ABP. So ABP, these two triangles we have to consider to find a linear magnification. So we can easily derive the relation, the ratio as ABP by AB is equal to PA by PA from the similarity property of the triangles. So here you can see from sign convention ABP is nothing. ABP is the image height and it is downward with respect to the principal axis. So it will always be minus is this. So this is image height. What about AB? AB is nothing but the object height. It is positive. And PA dash. What is PA dash? We can see here P. This is P and this is A dash. This is image distance. So it is negative V. And PA is the object distance. It will be minus U. So we can put all these values in this ratio equation and we will get magnification M is equal to H dash by H, or it is equal to minus V by U, that is minus object distance by image distance. So this is the linear magnification formula. So what we have concluded from this formula, first conclusion is that when M is greater than 1, so what will happen if M is greater than 1, then image formed is enlarged. So this image will be enlarged as compared to the object if magnification is greater than 1, and if the magnification is less than 1, then image will be diminished. That means the size of the image will be smaller as compared to the size of the object if the magnification is less than 1. And again, when magnification M is positive, image formed must be erect, that is virtual. So if M is positive, if we can say M is positive, then what will happen? The image will be erect and virtual. And if M is negative, then the image will be inverted, or we can say image will be real. And in case of concave mirror, M can be either positive or negative. So M may have any value, positive to negative. But in case of convex mirror, m cannot have a negative value, so it must always have positive value. So this is the important formula for linear magnification. Hope you have understood this concept of mirror formula and linear magnification, and in our next video we are going to discuss about refraction, refractive index, and there will be other videos in which I will discuss about total internal reflection in detail, then refraction at spherical surfaces and by lenses, thin lens formula, and we will find a relation of combination of thin lenses in contact. Then we will discuss about prism and rainbow formation, scattering of light, and we will also discuss about optical instruments like simple and compound microscope, telescope, etc. So if you have not yet subscribed this channel, I request you all to subscribe this channel so that you will get all the videos one by one in a proper organized manner. Thank you for watching. Inspire us to make more educational videos. So like, share and subscribe.